Hey, AP Chemisters, this is Mrs. Vanderbilt, hopefully bringing you the last of the 6.4. We're still talking about heat and work. So actually, we're just talking about work at this moment. So we learned at the end of 6.4, part 3, that work is equal to negative P delta V. So let's look at an actual problem here. To inflate a balloon, you must do pressure volume work on the surroundings. If you inflate a balloon from a volume of 0.1 liters to 1.85 liters against an external pressure of 1, how much work is done? All right, so let's find out. Here is my work, and they gave me this. So you have a pressure of negative 1 atmosphere. Well, it's negative pressure, so it's negative 1 atmosphere. Notice that this is my final minus my initial. Okay, I'll say it again. My final minus initial. So when I do that work, what do I get? I multiply it together and I get negative 1.75 liter atmosphere. Notice nothing cancels out. A liter minus a liter is still a liter. So it's a liter atmosphere. Is that what they're asking you for? No, they want it in joules. All right, so how many joules is negative 1.75 liters atmospheres? Well, what unit goes on the bottom? 1 liter atmosphere. What goes on top? 101.3. Where did I get those numbers from? From the beginning of this part of 6.4, like on the prior page. And then when you do your math, you get negative 177 joules. So don't forget to convert to joules. Again, I've been teaching AP long enough to know that this is a common mistake. Don't let that be you. Will you make a note of that someplace? That would be awesome. Now, this next question, I crossed out number 17. The reason being that this is, all the problems always had it inflating. And I wanted one that deflated. So I rewrote problem number 17 so the volume actually decreased. So let me put that new problem up here. So here's my new problem 17. I hope you make your adjustments too. It says a cylinder is what? Is depressed, all right, or decompressed with an external pressure of 1.58 atm. So that would be like arrow coming down. Is it on this page? Yeah. So that's one of these situations where you are compressing it, all right, you're shrinking that volume. All right, if the initial volume is 1.345 liters and the final is 0.485 liters, how much work is done by what, the system or the surroundings? So why don't you take a moment out and work on this and see how you do. All right, how'd you do? Well, I have this, and then I plugged in some numbers. And look what happens to your work. Your work is a positive 1.36 liter atmosphere. Why is that a big deal? Because your system, I'm answering the last part of the question, is doing work on your surroundings. The system is pushing down on your syringe or on your piston, on your cylinder. So because the work is going, from the surroundings to the system, it must be positive, and the numbers work out, so that works, to be a positive number. But wait a minute, I don't want it to be in liter atmospheres. I need to be in joules, all right? So there you go. I have positive 1.636 liter atmosphere. Liter atmosphere go on the bottom, 101.3 joules are on top, and there's my final answer in joules, positive number. Let's go to the next page, and then I think we're done. All right, can you do this problem for me, please? Pause, and when you're done, come back. Okay, how'd you do? Well, hopefully you wrote an equation down first like you always should. And then I plugged in some numbers. I have negative 15, and notice I have my expansion, so final minus initial is a positive number. So my overall work is a negative number, so it's liters and atmospheres. Of course, we can't do that. So then we need to convert into joules. Why only 2 sig figs? Well, 15 atmospheres, 2 sig figs. When I subtract it, I only got 2 sig figs, so I can only have 2 sig figs, okay? What about my next problem? So what's happening here? You're asked to solve for the work, but in addition, you have to solve for delta E. So this is a two-part problem. You might need to go back and review how to solve for delta E. So pause this, solve for work, then solve for delta E. When you're done, come back. Okay, so let's see how you did. Hopefully you paused it so you're not just watching me do all the work. Haha, get it? So anyway, here is my work is negative P delta V. I plugged in my work and or my pressure, my volume. Notice again that the volume is expanding so that my work is a negative number. And then I need to convert it to joules. Why did I have to convert it to joules? Because you have to add apples and apples, all right? You can't add apples and oranges. I have to have the same unit in order to add these two numbers together. So delta E of this system is Q plus W. Hey, what's Q? In addition, 575 joules is emitted as heat. Did you catch that? So the system is emitting heat. So is Q positive or negative? Q is negative. All right, so whenever you lose heat to the surroundings, Q is negative. So then I have negative 875 joules. I have negative, somehow I got 124 when I had 123. Don't know why I switched the numbers there, but I did, don't know why. And what did I get? I think I got negative 99 or 999. So I apologize for that. Make it negative 120 or make it negative 998 if you have to, all right? All right, so problem number 20, I think this is our last one. I hope it's our last one. This is a long section. A balloon is being inflated to its full extent by heating the air inside. Its final stages, the volume of the balloon changes from 4 million liters to 4.5 million liters by the addition of 1.3 times 10 to the 8th, so it'd be 130 joules of energy as heat. I believe this is going to be a hot air balloon. I don't think this is a party balloon. Assuming the balloon expands at a constant pressure of 1, calculate delta E for the process. So what's the first thing you have to do? You have to calculate W. Okay, so go ahead and calculate W, just like we did above, and then calculate E. So pause this and come back. All right, how do we do? Well, I always start off with my formula. How about you? And then I went ahead and I converted this into non-scientific notation. I don't know, I see it better that way. And when I did this, I subtracted, I got 500,000 times negative 1, I get negative 500,000 liter atmosphere, but can't have liter atmosphere. You need to be in joules, okay? And by the way, I then went and said, okay, that is negative 5 times 10 to the 7th joules, okay? I'm not done yet. I need to be solving for energy. So it's Q plus W. So what's happening with Q? Did you see what it says? By the addition of energy as heat. So heat is being given to the system. So is it a positive 1.3 times 10 to the 8th or a negative? Which one is it? If you said positive, you're right. Okay, so the addition, what just happened? The addition is going to be a positive number. All right, and I guess I need to scroll down a little bit more here. It's where I ran into trouble. Come on. Oh, I see what I have to do. There we go. And so I have a positive 1.3 times 10 to the 8th plus a negative, thank you, negative 5 times 10 to the negative or to the 7th. And when you do that, you get 8 times 10 to the 7th joules. So that's your final answer. That's how much energy was given into the system. I believe that is all for section 6.4. This is it. This has been long. I am sorry. But this is a really important section. It really is. So don't wait to be great. We'll see you next time. And thanks for sticking around. Bye-bye.